Hi everyone, welcome back. Today we shall discuss about RSA encryption algorithm from the subject cryptography, and the subject code is 18CS744. RSA encryption algorithm. So it is a type of algorithm which uses a public key encryption algorithm. To better understand, let us see what is first the private key and the public key encryption algorithms. Public key encryption algorithm. The public key encryption algorithm is also called as the asymmetric algorithm. These asymmetric algorithms are also the algorithms which has the sender and the receiver use the different keys for encryption and decryption. Each sender is assigned a pair of keys, that is public key and the private key. The public key used for encryption and that of the private key it is used for decryption. Decryption cannot be done using the public key. The two keys are linked but the private key cannot be derived from the public key. The public key is well known but the private key is a secure and it is known only for the user who owns the key. It means that everybody can send a message to the user using the user's public access, but only the user can decrypt the message using this private key. The public key algorithm operates in the following manner. So where first the encryption algorithm, where the first the plain text, then it is converted to the ciphertext using encryption algorithm. So that uses the public key, then decrypt that uses the private key. So hence the same plain text has been decrypted here. Then when the plain text after decryption algorithm, where it uses the private key, then to ciphertext that uses the public key, then the plain text has been obtained. The data is sent that is to be sent is encrypted by the sender using the public key of the intent receiver. B decrypts the received ciphertext using its private key, which is known only to B. So B replies to A encrypting its message using A's public key. A decrypts the received ciphertext using its private key, which is known only to them. So this is what we have seen in the previous diagram. Now we'll look into RSA encryption algorithm. So it is a most common public key algorithm that is named after the inventors Rivest, Ashimer and Adelman. So here the plain text, then it is converted to the ciphertext using the private key that is having the formula C is equals to M power E mod N, and the ciphertext is again been converted to the plain text using the private key by calculating E, D and N, where it has a formula M is equals to C par D mod N. So now let us look into RSA algorithm that uses a procedure generate the public and the private keys. Select two large prime numbers that is having the value P and Q. Multiply these numbers to find n, where n is equals to P into Q, where n is a number called as the modulus for encryption and decryption. Choose a number E less than n such that n is relatively prime to P minus 1 into Q minus 1. It means that E and P minus 1 into Q minus 1 has no more factor except E. Choose E such that E is less than E less than phi of n, where E is prime to phi of n. So we're calculating the GCD of E comma D of n, that should be always equal to 1. If n is equals to PQ, then the public key is E comma n and the plain text message M is encrypted using the public key E comma n, and to find out the ciphertext to the plain text following the formula it is used to get the ciphertext C. So where it has the formula C is equals to m power e mod n. Here m is much less than n and larger n it is concentrated, each of which is encrypted separately. So now to determine the private key we use the following formulas where ed mod p minus 1 into q minus 1 is equal to 1, or ed mod phi of n will be equal to 1. Then the private key is d comma n and the ciphertext is a message C using the private key d comma n. To calculate the plain text M from the ciphertext C, so following formula can be used to get the plain text M, where the formula tells us like M is equals to C par D mod N. Now we will look into one example how this RSA algorithm works, where we can encrypt the plain text using the public key encryption algorithm. So this example where I am using the prime numbers are 7 and 11 to generate the private and the public key. First step is to select the large numbers, that is p and q, where I have selected p is equals to 7 and q is equals to 11. Then step 2, multiply these two numbers like n is equals to pq. So n is equals to 7 into 11, where n gives the value as 77. Phi of n is equals to p minus 1 into q minus 1, where we'll substitute p and q value. 7 minus 1 into 11 minus 1. So phi of n value gives you as 60. Then now let us choose a relative prime number e of 60 as 7. So thus the public key, that is e comma n, will be 7 comma 77. So in step 4, a plain text message M is encrypted using the public key e comma n. To find the ciphertext from the plain text, following formula is being used to get the ciphertext C. So the formula here C is equals to e power m mod n. So where e power m, it is C is equals to 97 mod 77. So that gives the value as C is equals to 37. Step 5, the private key, that is d comma n. To determine the private key we use the following d formula. So d of m mod p minus 1 into q minus 1 will be equal to 0. So that is will gives the value d is equals to 43. So the private key d comma n, that is d comma n will be equal to 43 comma 77. So next step 6, a ciphertext C is decrypted using the private key d comma n. To calculate the m from the ciphertext C, we have the formula like m is equals to c power d mod m. So that is C value, that is 37, power 43, that is D value mod 77. So where it gives the value as 9. So in this example the plain text value is 9 and the ciphertext value is 37. Thank you all. Please do like, share and subscribe.